Alright, this video is going to be a very fast overview of the probability unit. Here we go. So the main goals are going to be to determine theoretical and experimental probability of an event, to describe changes in experimental probability as the number of trials increase, and then third, investigate and compare experimental probability and theoretical probability of an event. Alright, here we go. It sounds like a lot, but we've been doing it all year. All right, theoretical and experimental probability. Flip a coin 20 times. How many times do you land on heads? Well, theoretical probability is when you think about flipping a coin 20 times and you use a proportion to figure out what you're probably going to get. First, you do a single event probability, your desired outcomes over possible outcomes. So flipping a coin, you have a 1 in 2 chance of landing on heads. Now you set up your proportion, you figure out the number of trials, so what you want over the number of trials. Well, if we're doing 20 flips, that's going to be your setup. And then you can do your cross products to work out n, and you get 10. So theoretically, you're going to get 10 heads out of 20 coin flips. Now, experimental is when you actually get a coin and flip it 20 times. So you do the experiment. You keep track of what you flip. So let's say you flipped 20 times and these were your results. Then you would just take your heads out of your total flips. Heads out of total number of trials. So your number of heads for this problem was 12. So you got 12 out of 20 heads. When you flipped the coin 20 times, you landed on heads 12 times. So that's your experimental. So in this case, your experimental came out more than your theoretical. All right, now we're going to be working with a number cube or a dice. You roll a number cube 24 times. How many times do you land on a 5? Well, first we'll think about it and do the theoretical. For a single event, rolling a 5, you have a 1 in 6 chance. Now, when you're rolling 24 times, you're going to go ahead and say something out of 24. You do your cross products, you get n equaling 4. So that means theoretically, your theoretical probability for landing on a 5 is 4 out of 24. So the experimental probability is when you actually get a number cube and you roll it 24 times and you keep track of what you roll. So let's say you rolled 24 times and these were your results. Of those numbers, how many times did you land on a 5 over how many you rolled? So it's 6 out of 24. So your experimental probability for landing on a 5 is 6 out of 24. Moving on. Experimental probability and increasing trials. Okay, so we've got a spinner here, 5 sections. Which statement is most likely going to be true? The spinner lands on B 12 out of 60 times. The spinner lands on B 4 out of 20 times. The spinner lands on B 1,000 out of 500 times. Well, for a single event, for spinning a B, it would be 1 out of 5. All of these ratios break down to 1 out of 5 in lowest terms. So all of them have the same probability. The one that is most likely to happen is the one where you do the most trials. You spin it the most times. So you're most likely to get that 1,000 out of 5,000. You might not get it exactly, but it'll get real close to it, and you have the highest chance of getting that. Moving on. The more trials in the experiment, the more likely the probability will happen. Moving on. So we've got another number cube. Which statement is most likely going to be true? Out of 300 rolls, landing on a 2 50 times. Out of 60 rolls, landing on a 2 10 times. So that's 10 out of 60. Out of 180 rolls, landing on a 2 30 times. That's 30 out of 180. Well, for a single roll, rolling a 2, you have a 1 in 6 chance of doing that. all of these probabilities all break down to 1 out of 6 in lowest terms. So they all have the same probability. The one that's most likely to happen is going to be the one you do the most of. The more trials in the experiment, the more likely that probability will happen. All right, so we've got this table. We've got some number cubes over here, and this is how many times you rolled them after 24 rolls. This lists their frequency. So I rolled a 1 8 times, I rolled a 2 once, and so on. What will happen to the cube's number's frequency if you roll 6,000 more times? So here are the different scenarios. 6 will be the number that appears the least. The frequency for all cube numbers will get closer to the same number. 1 will be rolled the most amount of times. All cube numbers will appear exactly 1,000 times. Okay, 6 will be the number that appears the least. Well, 6 appeared no times at all, but it will appear eventually if you roll 6,000 more rolls. The frequency for all cube numbers will get closer to the same number. They will all get closer and closer to the same amount. That's going to be the true statement. The more you roll, all of those cube numbers are going to start to appear closer and closer to the same amount. Let's just double check the rest of these. Yeah, 1 was rolled the most in this first 24, but it will not continue to be the most. All cube numbers will appear exactly 1,000 times, not necessarily. They'll all get close to 1,000, but not exact. Okay, so comparing experimental to theoretical. So we've got this table, we've got 30 rolls, and we've got these results. What is the theoretical probability for rolling a 6? Well, if you're doing theoretical probability, you're not even looking at this table because this table shows experimental probability. It shows the experimental results. So theoretically, oh, and then the next question, what's the experimental probability for rolling a 6? So this shows the experimental results. To figure out the theoretical, we would be doing the whole 1 out of 6 equals blank out of 30. Because out of 30 rolls, theoretically, it would appear, each one would appear 5 times. A 6 should appear 5 times. Everything should appear 5 times, theoretically. What is the experimental probability for rolling a 6? Well, when we did the experiment, we rolled a 6 4 times. You could also see it as 2 out of 15. They might give it to you in lower terms. You never know. You have to be comfortable understanding that both of these represent the same thing. All right, next. We've got a spinner, 40 spins. We've got these letters, and here are the results. Which letters appeared less than the theoretical amount of times? Well, this is showing the experimental results. Theoretically, they would all appear 8 times because if you set up a proportion, each of these has a 1 in 5 chance of appearing. Out of 40 spins, you just do your cross product, you get 8. So theoretically, they'd all appear 8 times. So which letters appeared less than the theoretical amount of times? Well, C appeared 5 times, D appeared 6 times. So C and D appeared less than the theoretical amount. Did any letter appear the theoretical amount of times? Yes, E appeared the theoretical amount. Theoretically should have gotten 8, and he did the experiment, and he did roll E 8 times. All right, here's another cube. We're rolling. We have 24 rolls. Here are the results. The number 3 was rolled more, less, or equal to its theoretical amount. Well, I rolled a 3 6 times. This is showing experimental. Theoretically, everything should have appeared 4 times because 1 out of 6, a 3, you have a 1 in 6 chance of rolling a 3. Well, out of 24 rolls, that'd be 4. So theoretically, everything should have appeared 4 times. 3 appeared more than its theoretical. 6 is more than 4. How about 4? The number 4 was rolled more, less, or equal to its theoretical amount. 4 was rolled twice. Theoretically, it should have appeared 4 times. So it appeared less than its theoretical amount. That's about it. Hope this helps. Best of luck to you.